Good evening to everyone and very warm welcome. On behalf of the Institute of Engineers, Sri Lanka and the Electrical, Electronics and Telecommunication Engineering Sectional Committee, I am pleased to welcome you to today's webinar on developments in 6G and relevance to Sri Lanka. We are honored to have two distinguished Sri Lankan experts who are actively contributing to global 6G research. To begin the session, I would like to invite Dr. Geet, Secretary of the IESL Electrical, Electronic and Telecommunication Engineering Sectional Committee, to deliver the welcome speech and introduce our resource personalities. Over to you, sir.
Okay, thank you. Good evening, everyone. On behalf of the Electrical, Electronics and Telecommunication Engineering Sectional Committee of the Institute of Engineers Sri Lanka, I warmly welcome you all to today's webinar on developments in 6G and relevance to Sri Lanka. I am pleased to welcome all the participants joining us from across the Sri Lanka, engineers, academics, industry professionals, and students. Thank you for taking the time to be with us in this evening. We are honored to have two distinguished resource persons from University of Oulu, a global leader in the 6G research. First, it is my pleasure to introduce Professor Nandana Rajatheva. He's a professor at Center for Wireless Communication and the team leader at this 6G Flagship. He has many years of experience in wireless communication, 6G research, and AI-based networks, and has contributed to international research and standardizations. We are also proud that he is an alumni of University of Moratuwa and continues to support research connection with Sri Lanka. We are also delighted to introduce Dr. Dileepa Marasinghe. He worked as an AI RAN research manager and is a representative of the AI RAN Alliance. His work focuses on AI in wireless systems, sub-THz communication, and real-time intelligence networks. His research is helping shape the future of AI-driven telecom systems. We sincerely thank both our speakers for joining us and share their expertise. We wish you very informative and engaging session. Thank you very much.
Thank you, Dr. Geet. It's now my privilege to introduce our very own first speaker, Professor Nandana Rajatheva. Professor Rajatheva is a professor at the Center for Wireless Communications, University of Oulu, Finland, and the team leader for wireless access technologies at the 6G flagship program. He is an alumni of the University of Moratuwa and a globally recognized expert in physical layer, 6G research, and AI native networking. He actively contributes to international 6G standardization efforts and is also involved in initiatives supporting research and development collaborations connected to Sri Lanka. Professor Rajatheva, the floor is yours now.
Right. Thank you, Dr. Shani, and thank you, Geet, for the introduction. So let me start. Okay, so as you can see the title, it is Developments in 6G and Relevance to Sri Lanka. Actually, when Geet asked us earlier, then we were thinking of having the date yesterday. Maybe you don't have been a good choice given the cricket match that was to be played, and hopefully everybody is happy with the result. So let's get into the details today. Okay. Let's see. Okay, here. So we both are working actually in this flagship project, which started in 2018, and we are ending that project right now. So quite many people are working So as a background to what we have been working on. And we have quite a lot of white papers you can check in the website, and quite a lot of company collaborations accordingly. Of course, now a significant duration. When we started, it was the first research center working on 6G at that time, 2018. Not even industry was thinking about 6G then. All right. Right. So how we do this is at this point is we consider, so you can think of, how this research is done yourself as well. So one is we divide it into different strategic research areas. One is the connectivity solution. So how do you connect, of course, access point to the user terminal? And then device and circuit technologies, how to implement these transmitters, receivers. And then moving more on to the computer side of it, distributed intelligent wireless computing. And then, of course, there is this vertical services, human-centric services and applications. So, and if you look here, then you can see these technology enablers. We are mostly associated with that. Actually, I'm in this first strategic research area, wireless connectivity solutions. And then importantly, we also have a test network in the sense we operate as a regular operator within our university premises. We have all the equipment, access points and everything. And then, of course, we contribute to, like I said, these vertical applications and to the 6G vision leadership. And as such, if you look at these impact actions, you can see we are globally connected from Latin America to, or the South America to Japan. Importantly, as well, closer to Sri Lanka to India. And this will, of course, go on. Recently, Nokia Oulu moved very close to the university, so we have better collaboration with them as well. So, yeah, what we think, which is already to a certain extent is the situation, and there's a lot of data and people are working on a lot of various applications. And I think in Sri Lanka as well, there are a lot of applications being developed. So how we try to focus this into the research in wireless is something that we need to discuss. So accordingly, if we consider these critical drivers that we are looking into, if you compare with, for example, 5G, still this digital inclusion or the global coverage is not there. About 4 billion are still not connected. So that is something that needs to be addressed. And you can see these different disruptive business models and how do we collaborate globally. And increasingly, because of AI and associated developments, then there is the big issue of data privacy and security. So, and at the bottom, you can also see this smart AI enabled networks and applications. So how these are developed right now, this standardization is going on. At what point this will be frozen, we will see in a couple of years. So with that, therefore, if you consider the main aspects, you can see here at the top, there is, of course, sustainability. There is regulation that has to happen. And naturally, you need technology. But at the same time, these technology solutions must make business sense. So what I discussed earlier in the previous slide is reflected here in the sense that you need to, of course, incorporate machine learning. There is not much choice there because AI is developing in leaps and bounds. So we need to see. And so that was not as such available in 5G. And also what was at the same time not as available was this sensing aspect of it. Some degree of localization is there, of course, but we want to make it much more accurate and to have the network to see what is happening, have the situational awareness. So that is there, and those are different. And obviously, when it comes to this, if you especially consider 5G, there was this machine type communication. Now we think with 6G, this technology will mature. So those are the research things that one can think of when we are considering 6G and how things are going along. Now, specifically, if you consider from IT, UT or IMT 2030, so you can see this circle, it also mentions the sustainability and importantly connecting the unconnected. This was actually not there when the 5G standardization was considered. We did not really bother with, let's say, what we call non-terrestrial networks, NTN, which is now quite an important part. And another important aspect is, of course, security and resilience. I think resilience will play a key role in the development. I will discuss it a little bit more on this one. And once you look at the inside triangle, you can see what was 5G. Basically, we had some of these things, but then these are now expanding into these into this hexagonal actually. So this is some quite familiar figure, ubiquitous connectivity. And importantly, we are working on this AI and communication and this integrated sensing and communication. So these are important areas under research right now. And if you consider the capabilities, so new capabilities, you can see different on the lower side, you can see what are the enhanced capabilities that are needed. I think I have a table also on that. You can check peak data rates and AI related capabilities. Increasingly, we are always talking about coverage and positioning new capabilities. So what is there before on the lower half, what will come on the top, new capability, right? So this is how we see these 6G networks will be different from current 5G. As of course we know, in Sri Lanka, 5G spectrum is still being added. So we have to see how that will go also. So on that, actually, you can see the spectrum in 5G and how the spectrum would be in 6G. Like in blue, you can see current spectrum usage. So here on the lower side, you can see FR1, and on this side you can see FR2, and then there is this FR3, which is the essential this what we call centimetric change, and then there is this complementary sub-THz. I think Dileepa will talk a bit on that. Although FR2 is standardized, some networks or operators implemented it, the success is not that good in the millimeter wave side. So that is something in terms of research people have to address, right? So we can discuss this a bit more. As you can imagine, in the FR2 range, the coverage is short. So when the coverage is short, you try to do this in an outdoor environment, beams are narrow, so you easily lose line of sight. If you lose line of sight at millimeter wave range, then it is not good. So that's what happened, for example, in US, and so the uptake is not good. So most of the work right now is in FR1, right? So that's why people, I think, settled into FR3. All right. So I think this is in a nutshell what happened before the 4G to 5G. Mostly idea was to connect. 4G was actually this mobile internet, and 5G is connecting. And so the developments in 6G, as we see, is I think this metaverse is also kind of leaving the scenario. So what is there, what is coming is resilient and AI-driven society. So we have to see how this is. So this is kind of old picture, as you can see, 2023. And evolving last picture, maybe that would be the real situation with 6G. So these are some KPI, again, somewhat old actually. But if you see, always obviously when you advertise the highest possible things, terabit per second, and so on. And importantly, you need to have real, let's say, very energy efficient network. So energy efficiency is a key, and clearly to deliver those energy efficient networks, a lot of research had to happen. So that is what is going on right now. So specifically, if you consider these key areas, what are the, so there is the energy efficiency, sustainability, and I think you have that last is resilience. You had seen this. So increasingly, resilience is playing a role. How, I'll come to that in a minute. So if we identify key areas, Dileepa will elaborate on this AI native networks, how AI interface will change with neural receivers, and some, of course, at the transmitter side. Distributed MIMO, I think you have heard of this massive MIMO, but we are moving to distributed MIMO. And in terms of research to energy efficiency, there is this antenna muting. And of course, when you are transmitting, you need to observe the power spectral mask. So you need to have some RF enhancement. So this impairment, normally when you do research in communication theory, you assume these are perfect, but in real life they are not. So this digital pre-distortion of amplifiers to make them in an OFDM environment. And accordingly, there is something you can do with the modulation alphabet constellation design. And a big topic is, of course, this integrated sensing and communication, not just limited to radar. Actually, as I put here, these point cloud systems, LiDAR, camera-based systems are important. All right, so let me also show what we have. So we have this development already from 2015 and what we have equipment-wise. And at some point, you can see this 2025 ARC OTA system. I think Dileepa will go into more details. In a nutshell, what I can say is that we have all these small cells, our tower, and we operate a real mobile network within the university. So we can do a lot of trials. Some things we develop can be tested, and then we can work with the industry accordingly. All right. So as I mentioned earlier, and as you had seen in this IMT 2030 figure as well, so resilience is going to play a role. Resilience means these days we have quite a lot of unpredictable events, let us say. Unpredictable, Sri Lanka had also the cyclone Ditwa, I'll come to that. And even before, for example, we had this 2004 tsunami. Design criteria were changed actually. And then, for example, in US, you always have hurricanes, tornadoes, and like that. So how to make the system resilient? So we need to be able to predict and to need to take what kind of preemptive actions that we can take and how to protect, and also progression based on data. So where hopefully when we say data, the moment we mention that AI comes into play. So this is also very active area of research right now and has to be implemented in quite many ways in current networks also, right? What will happen if you have a blackout? And in Sri Lanka, this is also important as you go higher into renewable energies, because the energy production is unpredictable. And if you have electricity supply, power in the base stations, how would you take that into account? Okay, so accordingly, we had this resilience white paper, and you can actually download it and take a look at what are the things that are there. So the motivation, importantly, what kind of things you can do in terms of architecture, but importantly also technological enablers. So if I move to the next slide, this hopefully you can see there is the redundancy and reconfiguration, telemetry, all these things, but you can see actually from the user level to the orchestration level, access level is where we are mostly active. How these things and how the power will change, renewables, and there is, of course, this power transfer, right? So how we look at this from our side, an end-to-end 6G network architecture, how much of this is obviously eventually implemented as 6G, we have to see, but this is the current take on the research in terms of resilience. Now, coming back to this Sri Lankan context to some extent, if you look at ITU website, it shows this NETP, this National Emergency Telecommunication Plan, has to be in place to handle disasters. And so you need to be able to mitigate the risks that before they happen. Oh, right. And then you need to have proper preparedness and obviously response and recovery, right? These are the four key areas that is identified over there. And question is how much of it is included in our telecommunication networks in Sri Lanka, for example. In Finland, if you lose mains power, electricity power, the telecom network or the mobile network or the base station should be, they are supposed to operate at least 3 hours before the power comes back on. So those are the things that needs to be considered. And like as I mentioned earlier, what we had seen is this cyclone Ditwa, and basically what happened was most of the mobile coverage was gone for several days. And the reason is, so in Sri Lanka is still to implement this national NETP. And you can read this article by a former director in the TRC, which actually gives a better description of these things, referring to this ITU document as well. So these are the things that can be looked in terms of research over there. Now, going also across the across Park Strait, India has this Bharat 6G Alliance. It has been formed some years back, and there was also this daily declaration of how they see this 6G research. So maybe you can take a look at these websites and see how to formulate the research that you plan to carry out. And importantly, together with this in mind, together with the local universities, actually, we had a discussion on establishment of new research center in Sri Lanka. So the idea is to initially start on wireless and AI technologies, how this will facilitate research local research, and we already discussed with some universities, and this is something that is still ongoing. We have been talking to Ministry of Digital Economy, and we had one meeting there, and then we have been having follow-up meetings on that. And I think that's all from my side, maybe. So we can go to the questions later, right? Maybe Dileepa finishes first, or how is it, please?
So we can go to the question at the end, no?
Yeah, better.
End of the session.
Yeah, sure. All right then, Dileepa, go ahead.
All right. Yeah. First of all, thanks, Dr. Geet and ESL for inviting us for the presentation. I will try to sort of touch one of the points that Professor Rajatheva was making, like how this. I think you heard the word AI like multiple times during his talk. So we know that we are already moving into a AI type of world now, and we are in the AI era. So what does the mobile network has to do, and then how do we change the mobile network architecture, and then what are the considerations in this AI era? So this will be my presentation on that. And can you go to the next slide? Okay. First of all, I think you might already know that traditionally the mobile network is optimized for the downlink, and with the recent uptrend of lot of AI type of services activities. But this study from Nokia recently from Bell Labs that has come out is like we can see the AI traffic is bursty and unpredictable, and the main impact is also heavy use of uplink. For example, if you think about a lot of applications like somebody is using TikTok or like this type of video heavy applications on mobile, or even editing something on the mobile with the use of some generative AI, these type of applications in the future, it's going to heavily affect the uplink. And then low latency is also something essential for real-time AI use. If you think about nowadays, if you are using, I'm sure pretty much everybody is using ChatGPT or some type of LLM, but still these type of calls or whatever your prompts are going to your ChatGPT server somewhere in the we want to be like, sorry, we want to be sort of, if you want to really harvest the potential of AI, I think we have to go towards this real-time AI use. And if you have seen or heard the words about physical AI, which these big AI companies are talking, so this is where we need to go. And then, like I mentioned, where do you process this AI? That is also a huge consideration as of now. So some type of generative AI or some models, maybe you can do simple things on your device, but where do you process the AI workload is also a big question. So these three things mainly are impacting the way the mobile network should operate in the future. And this is where this AI RAN theme is also emerging. If you go to the next slide. So as a social infrastructure concept for the AI era, the theme AI native networks or AI RAN has come out, and this was sort of formalized as a theme for research and also deployments in Mobile World Congress 2024 by few large companies. I will tell it about it later about this AI RAN alliance. But the idea is our mobile network should support the AI workloads and support natively how the mobile network is operated for AI. And this conventionally, we know the mobile network is supposed to do maybe voice transmission and data transmission now, but how to go towards natively integrating AI in all operational but also service level things. So this is where this AI RAN social infrastructure concept has come out, and then this is being discussed, and even I will show that there is a lot of industry movement behind this now. And if you are really interested, you can watch this video on YouTube. This is coming from a large telco operator and a large company from Japan called SoftBank. Yeah, next slide, please. Next slide, Professor. Yeah. For like I mentioned, so the requirements for low latency and also a lot of AI type of things. I think example use cases which these could be like utilized are, for example, autonomous driving, how to do remote robotic surgery, natural conversations with AI robots, or even AI like real-time translation between two languages when you make a call. These type of things are the ones that are considered. And if you have been following a little bit about 5G or even before that, I think these things have been discussed in various arenas, maybe in edge computing, or even like in 5G, how to do machine type of communication, so ultra reliable low latency communication. But one of the main reasons I see also why this has not taken up as a widespread adoption, like we don't see a widespread adoption of these use cases, is maybe the some component was missing. And I think native supporting AI, and also the AI type of models were not even still available. But I think we are slowly moving towards adoption of these type of use cases now, and I think this AI RAN concept will definitely support or help build the infrastructure that is ready for this. Next one, please. So when we talk about AI RAN, this is formally sort of divided. This is this AI RAN alliance, how they have categorized why these AI native networks. On the left side, we have AI for RAN, which means like how to use AI to optimize or make the radio access network better. So on different levels, from RF level, I think Professor Rajatheva talked about some RF impairments. From RF level to like operation of network and net self-organizing networks, these type of things. This is where how to use AI for optimizing the radio access network is like looked at. And then if you come to the right side, that is where user facing services are looked at. So for example, how to use the radio access network to sort of enable different types of AI services. For example, multimedia apps, like I said, like real-time photo editing or video editing, video generation using generative AI, agentic AI. And also there's a huge interest in this public or private private 5G, public the mobile networks we know, but also private 5G, and also how to distribute the user plane and how to coordinate these type of things. So how AI on RAN looks at user side and service side of the radio access network, and how to like enable AI services. And then when you put this together, one of the most promising or important idea in this AI brand concept is, can you so we know that we want to run AI or do the AI inferencing, but where do you do this? Like I said earlier also, like whether you do it on your device, or is it on the edge, or is it on the back end of maybe on the cloud, like far away from somewhere, which also affects latency. So AI and RAN concept, the idea is to use the base stations, which is like the next compute form after your user equipment or the phone. So can we use this base station equipment to run AI workloads. Then it comes a question: can these stations support this type of workloads? And in this, in the next few slides, I will show how this has been explored and shown that we can use commercial off-the-shelf computing platforms like GPUs and do the radio or mobile network processing, plus also do the AI type of workload inferencing. And then in this AI and RAN category, we also want to look at, or people are looking at, how to sort of orchestrate this and share the compute resource between the AI and the mobile network functionalities. And can we dynamically sort of change the workload sharing based on the demand? Right. Next slide, please. Professor. Yeah. So then it comes why we are doing this also. So if you think about a mobile network, so connectivity is already there, of course, and we are looking at like how to improve connectivity towards 6G. If you like, you can see like Professor Rajatheva was talking about how to improve connectivity a lot, and it is already ubiquitous, but we are trying to improve that, and billions of devices are already connecting to the mobile network. But then if you look at the concept of AI and RAN, what we want to do is have sort of mobile AI inferencing capability on the base stations, which means since there is a really good geographical permeability all over, say, the land, this RAN infrastructure is best sort of positioned to become this global inference engine. That means we try to transform the mobile network not just as a connectivity platform, but the platform that delivers you AI to the house. It's like electricity you are getting from the power grid, water you get from the water distribution grid, but the mobile network is proposed as the AI inferencing engine where they deliver the AI to you, your connectivity to your mobile phones or the other devices. So this is where this AI and RAN concept has been taking a lot of traction. So if you go to the next slide, has this been successful? There were some recent demonstrations. So this first demonstration of AI RAN was done in Japan with NVIDIA GPUs. So what they have shown is you can use actually this commercial off-the-shelf GPU platforms and show that they showed that the shared infrastructure can sort of do this AI inferencing and also RAN workload processing on the same one. And what's important is traditionally, if you look at the base station, it's designed for peak capacity or peak data rates, but it's not always operating on that. So what they say, what mobile network operators have said is it's maybe 30%. The utilization is about 30%. But when we introduce this concept and we can share the rest of the compute for AI, this nearly goes to the 100% utilization of compute, and we don't have idling. And then they have shown also real-time edge AI, which sort of addresses this latency considerations. And more importantly, if you talk about anything that is compute, you have to talk about like how much power is being utilized. So what they have shown is these compute platforms are comparable to the current RAN power considerations, which means the total cost of ownership is almost the same compared to the traditional mobile networks. If you go to the next one, and building upon that, another demonstration of multi-user MIMO, which really hits the ceiling of like spectral efficiency. So this has also been shown, and the another important thing is what we can see is there's software defined operation rather than like purpose-built sort of hardware, so that whenever you want to do some updates, or this sort of enables you to give updates, like we get like software updates for our phones or devices you have. Since this is software based, we can upgrade, or if you do more, if you find a better algorithm that is working, we can easily do this software type of upgrade to the mobile network. So and this recent demonstration also has shown, like, I think roughly 3 times the spectral efficiency and throughput on a 16-layer multi-user MIMO. I think this was done in the NVIDIA headquarters in Santa Clara. Next slide, please. So one of the biggest catalysts or one of the pivoting points last year was like Nokia and NVIDIA struck a relationship or a partnership on this AI RAN domain. Of course, NVIDIA has the advantage of being the best GPU provider as of now, and they announced that they will invest 1 billion into Nokia. Nokia, maybe some people know that back in the days it was mobile, but Nokia is a huge player in the mobile infrastructure, although they don't make mobile phones anymore. And this is sort of a huge validation point, where the two of the biggest companies in this domain are trying to sort of popularize and also like show that this is working. And a demo was done at NVIDIA GTC DC in October 2025, which shows like how this AI and RAN concept, and also AI for RAN and AI on RAN concepts can be realized on already available mobile infrastructure. But the small change, or the change that they did, was replace this ASIC or the purpose-built RAN card with a GPU and run the whole compute stack of the radio access network on a GPU. And again, power considerations, they say that it is on par with whatever the traditional ASICs that are currently built by Nokia. One photo from GTC. Yeah. So next slide, please. This is the AI RAN Alliance, what I was mentioning about earlier. This is where actually this was formalized back in 2024 Mobile World Congress. So we are celebrating 2 years in few weeks in Barcelona. So it started as founding members are like Nokia, NVIDIA. From academic side, we have University of Tokyo and Northeastern University, Microsoft, SoftBank, Ericsson. So big players, and then now it has grown really like to a big consortium of members, both industrial and also as academic members. We are also supporting this and doing our research on this. If you go to the next slide, I will tell you what is AI RAN Alliance doing. One of the biggest concerns is, like, of course, when a new technology comes, or this type of adoption is pretty hard. So one of the aims of the AI RAN Alliance is also to like give out reference designs, because a lot of disaggregated components are coming together, and also a lot of software things are needed. So giving up blueprint or reference designs and blueprints for AI RAN is one of the main things that is being done from the AI RAN Alliance. And also in terms of technological companies, what we can the AI RAN Alliance is trying to provide is also benchmarking, where you can test one of your solutions with the AI RAN certified lab at a AI RAN certified lab, which you can sort of test your own innovative solution, and then sort of compare how it is standing with the other ones. And this is sort of helping and promoting to popularize and also show that how the AI RAN ecosystem will grow as the next step for the mobile networks. So if you go to the next slide. And yeah, when we talk about AI, I think one of the most important things that we have to also look at is data. So data is key for anything when you say AI, and in terms of telecom data and whatever is sort of needed, the AI RAN Alliance is trying to provide as a combined effort from the companies. There is a flagship initiative to provide data for AI as a service, or some sort of data sets for training your models will be provided. And then also when we come to AI, I think test methodology is also something very important, and this is also something that is being looked at from the AI RAN Alliance as a flagship initiative. And okay, this is like one slide about like from Flagship or University of Oulu side, what we have been doing. We have been mostly focusing in terms of research, I think, from this AI 4RAN domain, where we look at, I think Professor Rajatheva talked about digital pre-distortion, different levels of AI, how to use in the radio access network. And we have been sort of active in most of the European and these type of projects where this AI component has been looked at a lot. So this is an example of research from where we look at AI RAN. Yeah. Right. Next slide. And if you want to know a little bit more, I think in terms of relevance to Sri Lanka, what I see is things are becoming maybe a little bit software defined. It is moving towards software based platforms. And now you don't need to sort of have that the exact hardware, or like let's say some vendor specific hardware to do stuff. Even in research, things are moving towards the software side. So I think in terms of Sri Lanka, at least for research in this domain, it's becoming easier. And I think we've had a few discussions with local universities also, how to sort of go towards like AI RAN research in this domain because of this. And if you want to know a little bit more about like our recent activities on this, we have a biannual newsletter, and these are some example articles from that. And please feel free to read them. Yeah. Yeah, I think that was what I had in terms of AI RAN, and I think we can go to questions.
Yeah. So thank you, Professor Rajatheva and Dr. Marasinghe, for that excellent and engaging presentations. So let me briefly introduce about Dr. Marasinghe now. So he's an AI RAN research manager, 6G flagship at the University of Oulu, Finland, and a representative of the AI RAN Alliance. His research focuses on AI native wireless systems, radio access network evolution, and next generation 6D architectures. He is actively involved in major international collaborations, contributing to the advancement of future wireless technologies. So once again, thank you both of y'all. So we will now move on to the Q&A session. So with that, I kindly invite all participants to drop your questions in the chat box, or else raise your hand and grab this valuable opportunity to interact directly with our very own distinguished speakers. We will address as many questions as time permits. Yes, we have Supun Amarasinghe. You can raise your question.
Thank you, Professor Nandan and Dr. Dileepa, for your insightful presentation with the details. So my question mainly goes to Professor Nandana, because on his presentation, he mentioned that during this disaster times, there are special protocols we can follow in the network side. So I just want to know if there are any criteria to follow, like very ultra low power mode for the communication during these times, where we can optimize the available battery power and operate the network for a much extended time than the normal situation in this kind of situation. Thank you.
Yes, I mean, the existing configuration should facilitate that. I mean, we don't need to have any, high power operation, and even the services are at different levels, right? So even sending SMS, if we can maintain that, so that will conserve the power of the access point. So that is something that easily can be done, in my opinion. Only thing is that it should be, access point should be configured to operate in that mode. And importantly, like this, whether the access point has battery is another thing. Normally, it is supposed to have battery backup, and that is some area that can be investigated further. And whether, for example, in addition to battery, whether you have any generator available, those things. But in terms of the exact question you asked, of course, this is what is supposed to be done. I mean, to extend the operation as long as possible at the lowest possible power level. And I think the coverage also is higher when you go lower in frequency. So that is also there, I think, and all these things can be properly configured. And as I know, this should be feasible as of now. I mean, so yeah, that's what I can mention about this. Perhaps you can also say from your experience, what did you see? Super.
Yeah, Professor, thank you for the details. Yeah, because we face some network outages during that period, but I think properly configured, as you mentioned, I think that can be mitigated. I hope. Yeah, thank you very much for the details.
Yeah, this is anyway still like some question that is being answered also, given all these things that are happening, like whether there can be improvements. I mean, this is always an ongoing situation. Yeah. All right.
Yeah, so we have two questions in the chat box. Can you tell about the 6G waveform? Is it different than current OFDM?
I think the baseline is still OFDM, but there will always be some modifications to that. But as of now, it is OFDM. I think in the recent standardization meeting that they agreed that they will keep it in the same form. So yeah, I think Dileepa can mention about whether there will be any AI aspect of it to come in terms of learning whether to use a particular waveform or not.
Yeah, I think there are some study items looking at the possibility, but of course, in term at the waveform level, I think one challenge is you need a little bit of uh, a solution that works everywhere. So the problem with, let's say, machine learning and AI type of things is like it's about specializing to a certain scenario, and think there is some consideration maybe from the receiver side, but the waveform itself is currently, I think, agreed to go towards OFDM. There is also some study going on this OTFS, orthogonal time frequency, that waveform. This is a bit interesting towards integrated sensing and communication also. So I think, and then high mobility aspects people are looking at, but this is still, I would say, at study item level. So yeah, I think OFDM works really well. So
Yes.
things changing from that is as the mainstream 6G waveform, I don't think it will happen.
Okay, so there is this question about elaborate the role of semantic communication. I think this is an open question and it is very much scenario specific. Semantic communication works in perhaps what we call goal-oriented communication. Robot like to move to a particular direction. So some set of these commands can be semantically coded. And so those kind of applications in especially industrial environment where you don't need to have so much data to be transmitted in terms of control, especially for control. I think this will work. We have been also, I mean, we have a big group on the semantic side. We ourselves had worked on image transmission. So it is a form of source coding, how much information you want to send. And therefore, yeah, this is can be integrated to any communication network, and especially on the receiver side. Therefore, this AI aspect to train to expect what is coming, I think that is where AI native part will come into play. Yeah, that's what I can say, but Dileepa can say also something on this.
Yeah, I think in this semantic communication, so the idea of extracting semantics and trying to sort of reduce what you want to transmit, that's the idea in the semantic communication. So as Professor Rajatheva said, it's sort of source coding approach, but maybe highly specialized to different scenarios. There is, I would say, at research level, not at the standardization or even at like considerations at the maybe mobile network operator or this type of level, it's not still there, but a lot of research is going on. Can we do this, especially with the emergence of a lot of these large models? Can we use this to somehow reduce what we are transmitting and also do it in a more secure type of way? These type of things are being researched. So that type of role is, I think, is at some point maybe in highly specialized cases will emerge in the networks also. So
Okay, so thank you for all the answers. So if you have any more questions, you all can raise now. Okay, then seems like no. So once again, thank you for answering to all the questions raised by the audience, Professor Rajatheva and Dr. Marasinghe. As we come to the end of this session, it's my pleasure to deliver the vote of thanks. So, first and foremost, I would like to express our sincere gratitude to Professor Rajatheva and Dr. Marasinghe for sharing their valuable knowledge and global insights on 6G technologies and AI native networks. Your presentations have greatly enriched our understanding of the future of wireless communications and its relevance to Sri Lanka. I would also like to extend my appreciation to the chairman and members of the Electrical, Electronics and Telecommunication Engineering Sectional Committee for organizing this important event and a timely webinar. My sincere thanks also goes to the Institution of Engineers Sri Lanka for for providing this valuable platform for professional learning and knowledge sharing. Finally, I would like to thank all the participants for your active participation and contribution to making this session a great success. With that, we conclude today's webinar. Thank you all for joining us and have a pleasant evening. And we look forward to welcoming you to all the future ISL events. Thank you once again.